composite functions. So here we are going to discuss about the composite mappings under the advanced level. So here we are going to suppose two functions, say f and as well as b. Then so function f is of from a to b, that is a into b, and the next mapping, that is function g, is from b to c. Then the composite function of f and g will be denoted by means of GOF, G circle f or G composite f, which is given by means of a to c. So here let us suppose, or in other words, let us assume two functions, say f and as well as g, whereas function f maps from a into c, a into b. So here function f is mapping from a into b, and function g, that is maps from b into c. So here we are going to assume the functions as one as a, the second function as the sets as one as a, the second set as b, the third set as c. So here first function f is from a into b, and the second function g is from b into c. Then now when we assume, so here at small a be an element which belongs to a, when we are going to assume one element, that is a, small a, which is belonging to this first set, that is a, then image of this a, that is f of a, will be equals to b. So image of the small a will be in b. So here image of f of a will be in b, that is f of a will belongs to the second set, that is b. So, or in other words, so here f of a, so here f of a image will be of in b. So here f of a will belongs to this particular set, that is b, but function g is from b to c. So here b, set b is of the domain elements, therefore so here f of a will become the domain of that particular function, that is g. In other words, f of a is an element of the domain of function g. So here we assume three sets, that is a, b and c. So set a, in set a we are going to assume one element, that is a, which is belonging to this particular set a. So here f of a is equals to b. Say image of this particular a which belongs to the first set will be in b, that is f of a will be equals to this b, or in other words f of a is belonging to this particular set b, but function g is from b to c. The elements which are present in this set b are the domain elements of g. So therefore f of a will be an element of the domain of the set or the function, that is g. So here we can find out, now we can find out the g image of f of a, or in other words b. So here we can find out the G's image of f of a, which certainly present in case of C. So the domain of B, that is f of a, will present in C. So here therefore here we can find out say here G image of f of a in set C. So here that implies so it can be defined by means of, so here the image of, that is G of f of a can be given by means of G circle f of a. So here then the new function so obtained is from set A into set C. So here hence this new function is said to be called as new function so obtained is called the composite function. And now the composite function of f and as well as g is given by g of f, or in other words product of function f and as well as g. And now so the actual definition of this composite function, say in the next logical step. So here we are going to now the definition of the composite function is of. So here we are going to assume, so here first function f which is from A into B and as well as the second function that is g from B into C are two functions. So here, so this is the first set that is A and this is of the second set that is B, third set is of C. Then now, so first function that is f is from A to B and the second function g is from B to C. So here we can write it as function f is from A to B and function g is from B to C. Then now in order to find out the composite function of f and g, the composite function of f and as well as g is given by g of f. In case if you want to find out the composite function of g and f, then it will be given by means of f of g. And similarly, say this symbol indicates similarly composite function of g and as well as f is given by f of g. So in order to find out g of f, so we have to take first f then g. So in order to find out the composite function f of g, so we have to take first we have to consider g then later f. So here in order to find out the g of f, so first we have to consider f then g. So here it is from, so here g of f will be from a into c. Say here we have confirmed that here in order to find out g of f, first we have to take f and then later g. So similarly here in order to find out g of f, first we have to take f then later g. So f is from a, then now here g to c. Therefore here GOF will be of, that is g composite f will be given by means of a into c. Then now, so here based upon this condition, let us perform one example. So under this example, say here let function f is given by means of the ordered pairs 1 comma 3 2 comma 5 and then 3 comma 7, and the next function, that is g, is given by means of 3 comma 7 5 comma 9 and then 7 comma 10. Then now, so we have to find out g circle f, or in other words g composite f. So here first function, so here solution starts now. In our solution as per problem, the first function, that is f, is given by means of f is equals to set consisting the ordered pairs 1 comma 3, so here 2 comma 5 and 3 comma 7. Then now the second set, that is g, is given by means of, so set consisting 3 comma 7 5 comma 9 and 7 comma 10. So here we have to find out GOF. In order to find out GOF, so we have to, first of all we have to take f then letter g. So here in order to find g circle f, so first take f then g is the condition, whereas vice versa, in order to find out the f of g, then first we have to take as a g then later f. Then now here first of all we have to take here the f function and here g function. F function is from, so 1 comma 3, so that the elements are of 1 to 3 and 2 to 5, so here 2 to 5 and the third order pair is of 3 comma 7. Then later, so here function g is from 3 comma 7, so g is from 3 to 7 and 5 to 9 as the second order pair, so 5 to 9, and the third order pair is of 7 comma 10. So here, say in order to find out GOF, so here we have to find out, that is from f to g, that is from, first of all you have to take f and then letter g. So here it is of from 1 to 7, that is from a to c. So here elements will be of 1 comma 7. So first we have to take f then g. So here first we are taking as a here 1, so 1 to 3 and 3 to 7, therefore the ordered pair will be of 1 to 7. So as per the condition of the composite function, say 2 comma 9 will be the next ordered pair, then the 3 comma 10 will be the last ordered pair. In this manner we got g circle f, or in other words g composite f is equals to 1 comma 7 are the first order pair, 2 comma 9 and 3 comma 10 are the next two ordered pairs.